Okay, so let's do the question number 13. So let's just read the problem. So I have 1.2 gram of unknown sample in 50 gram of benzene, and then this solution freezes at 4.9 degrees Celsius. Now we need to calculate the molecular weight of this unknown compound. That's pretty much what we need to do. So I not only actually copy down everything on this particular problems, but also I did a little bit of information from the I got a little bit more information than the from the table. So the formula that we are going to use, because we are dealing with the freezing point temperature change, right? So the what we are going to use is this formula right here. The freezing point of the solution is the 4.92 degrees Celsius, and then pure freezing point is 5.48 degrees Celsius. The Kf, you look it up on the table, then you get like a 5.12 Celsius divided by m, and then we are supposed to get the molecular weight. So I know this one, I can calculate by using these two numbers, and then I can also get this information, which is this one right here, right? Then I can calculate that one. So that's the starting point. So let's put everything in Excel. So let's just not forget that one. So let's do the question number 13. So the formula that we are going to use, again, it's the same formula. And then freezing point of this formula, freezing point is 4.92 degrees Celsius. Degrees Celsius. And then freezing point of the pure benzene is 5.48 degrees Celsius. So the delta TF, I'm going to calculate this one on the spot, which is going to be positive number. It's the temperature being lowered, so it's actually the negative numbers, but we take it as a positive numbers, so it's the difference in temperature is 0.56, and then Kf is given, right? So we can actually get M here. The Kf is 5.12 C divided by M. Oops. So M, we're going to solve by using this formula right here. So M has to be this number divided by that, right? So the molecular molarity, molar is 0.111 basically. That's the molarity, right? So this means that I have 0.111 mole per every kilogram of the solvent in 1000 gram solvent. Okay? But I only have what, 50 gram here. So how many, what's the number of mole? This is number of mole, right? Maybe this is, I should probably put the number of mole of solute in So if I had 1000 gram of solvent and you know that you have 0.11 mole of solute, if I only have 50 gram of solvent, what is the number of mole here? Just simply divide by the same number here, right? So it's gram solvent. Let me just try to write this here. You can actually think of it as this divided by that is equal to this divided by that, and then just simply do the calculations by solving the ratio, or you can actually get this divided by that is a 0.05, so I'm gonna have to multiply this multiply by this. You get this. So basically that this over this is equal to this over that. Alright, so I figured out the number of mole of solute in 50 gram of solvent. But now that because it's a 50 gram of solvent, I also know that this one right here is 1.2 gram in 50 gram solvent, right? So let's just compare these guys right here. The solvent is pretty much the same. So we're comparing apple and apple here. Then 0.0055 mole corresponds to 1.2 mole. Right? So mass divided by the number of mole is going to give you the molecular weight, right? So molecular weight is going to be mass divided by the number of mole. That's going to be the molecular weight. So that's gram per mole. So that's pretty much all there is to it for the question number 13.